All right, so now we're going to look at velocity time graphs. And velocity time graphs are typically the ones that are going to cause people some issues. So let's break it down and understand what different graphs are going to look like on a velocity time graph. First off, our y-axis is our velocity. So we have to understand it's not showing us where we are, it's simply showing us how fast we're moving and in which direction, right? Anything that is moving in the positive direction is going to be above our x-axis. Anything in the negative direction is going to be below our x-axis. And if something were to be traveling at zero velocity, so something that's not moving, it would be graphed on the y-axis. All right, so the biggest thing that we have to understand, if our graph is on the x-axis, if it was graphed on the x-axis, that gives it a velocity of 0. That means it's not moving. Anytime that it is moving, then it's going to either be above or below the x-axis. Now, what about something moving in the positive direction at a constant velocity? Well, that would be something that just maintains the same velocity. So this is moving at a constant velocity. If we were moving faster than that, we would be higher on my graph. If we were moving slower than that, we would be lower on the graph. These are both moving in the positive direction at a constant velocity. The blue line is traveling at a faster velocity than the red line. This is maybe positive 10, this is maybe positive 5. Same thing in the negative direction. This would be a fast constant velocity in the negative direction. And the red one would be a slow constant velocity in the negative direction. So what we see is the closer we are to our x-axis, the slower that we're going. Right? This is a slower velocity than the blue one. Blue one again is faster than the red one. So that's showing constant velocities. Not very often though, in our year, our velocity is going to be constant. So let's look at a few examples of when the velocity is not constant. All right, our first one, we're going to start at a velocity of 0. So we start at our x-axis, and we're just going to do this. What this is showing a positive velocity that is increasing. We're going from 0 to 2 to 4 to 6 to 8 to 10. So that's a positive increasing velocity. So now what we're going to try to understand is, okay, what does the slope of a velocity time graph tell me? And what's the area? And I'll explain that in just a second. So first off, the slope. Now, time is typically going to be measured in seconds. Velocity is typically going to be measured in meters per second. So remember, slope is rise over run, which is the change in y over the change in x. So if I try to find the slope of this is my initial velocity from here to here. This is my final velocity, right? So my rise, this is my rise. That is telling me the change in velocity from there to there, right? So my slope is a change in velocity. My run is how much time went by. What does that tell me? That is acceleration, okay? A change in velocity over time. So the slope of a velocity versus time graph is acceleration. Our units are meters per second, which is also meters per second squared. So our slope tells us acceleration. It tells us both the value of the acceleration as well as the direction, right? This has a positive slope, so it has a positive acceleration indicated by my slope. That's great. So now, what does the area of the graph tell me? If we look at this, what I mean by area is the area under the curve to the x-axis. So that is the area. What does that actually tell me? Well, I think it's actually easier to understand if we have just a horizontal line. So let's do another example, and we'll have a negative velocity here, right? A constant velocity. And so my area is again from the x-axis to my line. Right? This is a positive area, this is a negative area, right? Well, what does that tell me? So if I were to find the area of this shape, I would basically do length times width. We have a rectangle, right? The length would be from here to there. That is measured as time, okay? That's measured in seconds. If I multiply that by my width is this. That's a velocity. That's measured in meters per second. And what we get is when we have seconds times meters per second, the seconds cancel out, and that actually gives me my displacement. Okay? So the area is your displacement. And the displacement can be either positive or negative. If we look up here, how would I find this area? Well, I'd find the area of a triangle. I do 1/2 base times height. And that's how I would find the area of that one. This one, length times width. It's based on the geometry of the graph, right? This again was a positive area, meaning it has a positive displacement. Well, if it has a positive velocity, it must be going in the positive direction. It's going to have a positive displacement. This one had a negative area. That means it has a negative displacement, right? Something moving in with a negative velocity is going to have a negative displacement. It's going to go from a more positive position to a more negative position. Okay, so lastly, I just want to go through some different shapes that you'll find on a velocity versus time graph. And here's what I will try to emphasize, right? Remember that this line represents 0 velocity. That is the main key that we need to understand to know if something is going faster or slower, if it's speeding up or slowing down. We've already showed what constant velocity looks like, right? So if something is moving towards 0, if something is moving towards 0, well then that means the velocity is decreasing. If something is moving away from 0, well that means its velocity is increasing, it's speeding up. So we're going to use that as we're looking at different shapes and different plots on the graph. So our first plot, just like we had before, is going to be, this is going to be a positive velocity that's speeding up. What we see here is we see a velocity starting at 0 and getting farther away from 0 in the positive direction, so it's speeding up. Same thing as this, that would be the same thing, a positive velocity that is speeding up. It is moving away from 0 velocity, its velocity is increasing. Opposite of that would be this. This is something with a positive velocity. They're both moving in the same direction. Both the blue and the purple are both moving in the positive direction. This one is speeding up, this one is slowing down. We can tell that it's slowing down because it reaches 0. It's moving closer and closer and closer to 0 velocity, which is indicated by my x-axis. Typically, those are okay. We can understand those. The tougher part is now let's get down into the negative region, okay? The negative region, let's look at this. The most common mistake is, well look, this one's speeding up, and so this one is also speeding up, but that's not true. This is a negative velocity. And look, it's moving towards my x-axis. What does the x-axis mean? 0 velocity. So this is something moving in the negative velocity, in the negative direction, but it's slowing down. -5, -4, -3, -2, -1, 0. Remember, negative is just a direction. So something going from 5, 4, 3, 2, 1 in terms of its velocity is slowing down. All right? Lastly then, this is negative velocity, but speeding up. Again, it's moving away from our 0 velocity line. That means it's getting a greater and greater and greater value or magnitude of its velocity, right? -4, -5, -6, -7, -8. It is increasing its magnitude, it is speeding up. Negative just tells me the direction. All right, so these are typically a little bit harder, so you gotta make sure you're paying attention and just think about Is it going towards zero or is it going away from zero? And that can help you understand if something is speeding up or slowing down. That could be a little bit more complicated, right? Here's an example of an object. What is it doing? Well, first, it's moving in the positive direction, so it has a positive velocity, but it slows down. What's it doing right here? Its velocity is 0. And then it starts moving in the negative direction, and it speeds up. So this is something that was moving one direction, slowing down, comes to a complete stop, and then starts backing up the other direction, but it speeds up as it's doing that, okay? Now, going to this, our slope we can find, that's our acceleration. What would my displacement though be? So with this, we'd have this area here, and we have this area here. And remember, this is a positive displacement, this is a negative displacement, right? And so something could, to find the total displacement, we'd have to add those two together, right? This could be something that starts at a position, is already moving, slows down to a stop, and then really returns to that initial position that it had. So that's how you'd find the area with this type of graph. Our last example is going to look at a graph that might look something like this. Now, what is this telling me? This is telling me something's moving in the negative direction. It has a negative velocity. And what's it doing? It's going towards the 0 line, so this is slowing down. It gets here. It touches the 0 line, so this is where it stops. Just for a moment, and then it starts moving in the same direction. It keeps moving in the negative direction. It doesn't turn around. This is always moving in the negative direction besides the moment where it stops, right? And what's it doing here? It actually speeds up. Slope, you'd have two different slopes here, so you'd have to calculate those separately. And then the area, right? How could we find the area of this? Well, the area would be this area here, so we'd find this triangle, 1/2 base times height, and we'd also have this area there, 1/2 base times height, okay? A lot of different other examples that you could go through with velocity time graphs, but if we can simply remember in terms of what's it doing compared to my 0 velocity line, that's going to help us a lot as we're working through understanding how to use velocity versus time graphs.